Hello, and welcome to this guest webinar series presented by Peel3D. My name is Francois Leclerc. I'm product manager at Peel3D, and today we have the chance of having with us Mr. Tyler MacCormack. Hello, Tyler.
Yeah, thanks for
So,
having me, Francois.
sure thing. Welcome. Thanks for being with us today. It's very appreciated. So Tyler is, of course, the owner and founder of Reversion Raceworks. And the reason we're here today is to talk about 3D scanning for automotive entrepreneurs. Before we get started, I need to let you know that if you have any questions during the presentation, you may ask them through the question pane of the GoToWebinar interface. There will be a Q&A at the end of the session, and yeah, we'll be able to answer any questions you might have. So enough said, let's get to the fun part of this presentation. And so, Tyler, what car is this, and what can you actually tell us about it?
Yeah, so this is actually a prototype Corvette that GM had put together in 1959, around there or so. I think it was debuted in 61. It's the XP87. This project was put together by Rob Ida, and we were contracted to work together with him to basically take a 1963 Corvette and modify the body and take a lot of style and design cues from the original prototype car and apply them to essentially his interpretation of this car, but in coupe variation, because all of the prototypes that were made were, as you could see, a roadster.
Yeah, okay, so this was a pretty unique car, right?
Oh yeah, big time, big time. So this was really like GM kind of messing with some style cues and really developing what would turn into the C2 Corvette. But once engineering, all the safety regulations or whatever gets in the way of the designers goes from their prototype to what actually was released in the production sense. So we like to believe that this is really what more of the intent the car was supposed to be from a designer perspective, and but that can be difficult when you're going to production.
Of course.
So but we luckily, with us being more of a bespoke hot rod shop, there's no problem with us just making one of them.
And yeah, so we have some more images of the car, and it's pretty radical as we can see. So those are different inspirations, right?
Yeah, yeah. So these are some pretty great angles where you could see the quarter panels are much more pronounced. The like rear tail panel is very sharp. There's a sharp body line going throughout the car. If you look at the front fenders of the car, they're pretty pronounced, and like the hood scoop very pronounced, and all those are like very similar features to what was on the production Corvette, but definitely a little bit different when it comes to the prototype car. So we essentially just took a lot of these style points and tried to apply them now to the coupe that we're working with. And I mean, otherwise you'd be doing this like with clay, modeling it all by hand, like a lot of iterative process with foam or what have you. This is where the modern technology of like peel and 3D printing and all the technologies we're going to go over today, where we can scan what's original, model it on a computer screen, and pretty much create a much more accurate representation of what we're even trying to create before it's even made. So it's just such a great manufacturing aid as to what would have been done in the past. Just we're just trying to make our job a little bit easier, because at the end of
Hmm.
the day, there's a lot of work to be done, and this doesn't take away from the craftsman in any form or fashion, because you still have to be talented enough to install it on the car and do all the proper body work and all that. But if we can model one side and mirror it so that we know both sides are perfectly symmetrical or something like that, why not make our life a little bit easier at the end of the day?
Yeah, absolutely. And one thing I just noticed, and yeah, I'm going to ask the question is, I see this as a single seater. Is this something that you're going to draw inspiration from in your design, or do you plan to make it a two-seater?
Ours is a two-seater. I could be wrong, but I believe the passenger side is like a cover that they put over because
Oh,
it was
I see.
intended for like a race car.
Okay.
So that would improve when they're racing to for the aerodynamics of it and whatnot.
Mm.
Because I believe I've seen a two-seater variation of this, but I could be incorrect. But
Oh, that would make sense. Yeah.
yeah, I think there was maybe 1 to 3 of these made. It's definitely like super, super low production.
Yeah.
Yeah, so
So
this
this
is
is the beast, huh? This is
yeah,
the first step of the project. So what's going on here?
yeah. So believe it or not, the car before it even came to this point, it came in for paint work. So, and we did a little bit more than finish up the paint work. Well, I shouldn't say we, more so Rob and his guys. They're the talented body guys. I just try to help them with the engineering of it. But as they were progressing with the project, they kind of found some things they wanted to change, and it kind of snowballed into being much more radical of a project than they intended. So from here you could see the roof was actually chopped and brought down about inch and a half, 2 inches. It was also brought backwards. So
Mm.
this is we did chop the top on a '63 Corvette, which some people love, some people hate, but we did do it. um, we heightened the quarter panels. The nose was lengthened about 2 inches, and yeah, it's just making all the glass fit and whatnot. And yeah, so a lot of this was done by hand and just taking either reproduction panels and fitting them to the car. But there's a good bit, as I'm sure you could see from the prior pictures,
Mm.
that you couldn't just buy off the shelf. So that was where we used 3D scanning for the hood scoop, but also the tail panel, which is what we're
Yeah.
really going to dive into.
Yeah, we'll get to that part shortly. Just before we move to the next slide, what's that wood structure there on the hood?
Yeah, so the Corvette initially had it had fenders and a front bumper panel and a hood, like a separate hood panel. We modified that so they're all one piece. So this is the Corvette traditionally has a clamshell hood where it will open upward, but in this case, the fenders, hood, and everything are now one piece. So it's going to be a full clamshell.
Wow.
So the wooden plywood was just to add some rigidity. As you
Mm.
could see, like the panels are just kind of clecoed together around the wheels, like they're not fully fastened together. So this was like getting the rough shape you wanted, and the wooden structure just keeps it rigid as you work on it to make sure like nothing's really moving around.
Nice. All right. All right. So what do we see here?
So this was the 3D scan of the rear panel. You could see like the classic uh, teardrop from the back of the Corvette and the rear of the quarter panels, but we have no tail panel because the tail panel on this prototype car is radically different from
Mhm.
what was on the Corvette itself. So basically what I did is 3D scan what was pre-existing, did like aligned it all, found a good coordinate system to work off of, and then that gave me like the base geometry, base reference point to create what we need to complete this car.
Right, right. So you can see the lip of the actual body and where it ends and what the actual shape of it is, right?
Yeah, yeah, and I did get inside and outside too, so you can get like
Okay.
that thickness of it because that gives me like a good reference point of like how we should lay the panels, like where do we want the fiberglass to lay in relation to what's pre-existing,
Right.
because you do need to bond the two panels together. So there are some like manufacturing considerations to be made there as well.
Great. All right. Let's try this like, oh, so this changed a lot.
Yeah. So this was some pretty extensive surface modeling where I was taking what I wound up doing actually, and this is where I found another benefit that I don't think a lot of people talk about with 3D scanning is one quarter panel was like slightly off to the other one. And for by eye, it looked great. Like you really couldn't tell the difference, but the computer tells all at the end of the day. And once we had everything lined up, like found our middle plane and everything, I essentially only modeled half of this. And then
Mm,
I wound up using the driver side as like my master side,
mhm.
and then mirrored it to the passenger side where it was maybe, let's say, a quarter of an inch off. Like it wasn't off by a crazy amount, but if we have the opportunity now to fix it and make our body work even better than what it was before, we're definitely going to take that opportunity.
Of course, yeah. Yeah, no, that's pretty useful to be able to mirror things because if you had to do it by hand and by observation, it's a whole different thing, huh?
Oh yeah, without a doubt. It's so hard, and pretty much I'm
Yeah.
sure any body guy can speak to, it's essentially impossible to get true symmetry when you're
Hmm.
making things by hand. You're just really trying to make it as good as you possibly can.
Yeah. Yeah. And then the other hand, then the car is not perfectly symmetrical either. So the
Hmm.
good thing is, you can know it comparing it to the actual 3D scan data.
Yeah, absolutely.
Great. All right, let's move on to the next slide. Oh, okay. So this is kind of a more of a projected finished product, right?
Yeah, yeah. So this was the surface that I basically considered to be the master of the project.
Mm-hmm.
And so like the surface basically got us the shape that we wanted, what we wanted the end product to be.
Hmm.
But we weren't going to like 3D print the body panel or anything. So I used that to aid me in modeling the mold.
Hmm.
And the mold we used to then lay fiberglass and whatnot, and made sure to add like appropriate draft angles for like around all the lips of the body panels, as well as inside the taillights. There's some draft, and basically any way we could make this as simple as possible. So this is what the shape we used to make the mold at the end of the day.
Yeah. And what CAD software did you use to do that?
This was all in SolidWorks.
No,
So
SolidWorks.
yeah, we used PeelOS and PeelCAD to like
Hmm.
derive some planes and whatnot, like get some base geometry. And then once we got those tools to help us, we imported it into SolidWorks.
Nice. Oh, so what do we see here?
This is the mold itself. So this we actually 3D printed, and each of the major lines is essentially representing an individual part,
Wow.
because internally we have six 20-inch cube 3D printers. So we busted it down into multiple parts that were like much more palatable for the printer. Because sure, you could
Mhm.
make it fit that full build volume, but you might be sitting there 2-3 days for a part, versus I tried to make it like about a, I don't know, 24-hour turnaround per part, which still is a good amount of time. But when you have a couple printers, and at least it's not man hours,
Yeah.
it's not too bad of a process.
So you're saying that you actually built a car part mold out of a regular 3D printer?
Yeah, I mean they're nothing too crazy. I mean we modified them ourselves to our liking, but we even just used PLA. Like it wasn't anything. It's not like we're using some super crazy carbon fiber nylon or polycarbonate or
Hmm.
whatever higher end engineering filament. Since this is a one-off application, we just used PLA, and we've done that on multiple different molds before too. So we knew it would work, and it's definitely a much more cost-effective route too.
Yeah, this is fascinating. And do you have to design any specific interface for the different parts to stick together, or just glue them? How'd you process?
So what I do with these typically is on the mating surface, so like in between where all those lines would be, I'll usually add, I don't know, 2 to 5 dowel pins, and I'll just use those as like a guide point to make sure like everything's snapping together where it should.
Right.
And then sometimes we'll use like an epoxy of a sort to adhere them. In this case, we actually made an MDF buck to like cradle it, so it held it underneath it, and I could show that in SolidWorks a bit later. But uh, in this case, we really just used the dowel pins and a little bit of hot glue. So we really took it the simple route.
Fascinating. Wow. Great. And oh yeah, so now we see here the finished product, right?
Yeah, so that's the print all thrown together. You could see the MDF buck that I was talking about.
Mhm.
That was, we kind of use that just because it is a bit of an obscure shape, and we could have like gone all the way down with the print, but it would have just added so much material cost and time. It was much more cost effective for us to laser cut a buck
Right.
to hold it and then have all these 3D printed parts put together.
Yeah, because actually the only organic shape you care about is the shape of the car part, right?
Yeah, yeah, because
Yeah.
otherwise it's just kind of wasted material.
Hmm. And how'd you deal with the inside surface of the mold? Do you have to apply anything special in order to build the part afterwards in order to mold it, or?
Yeah, so in some cases you want to like body work the mold to perfection with like gel coat and whatnot,
Mhm.
and use whatever fillers you want to get rid of all those seams. In this case, we really didn't go crazy with the body work on the mold itself because we still needed to body work the panel onto the car itself. So we
Oh,
kind of
okay.
were trying to pick where do we want to put the body work? Like where do we want to put the man hours?
Mhm.
And to us, it made the most amount of sense. Like, let's just make the rough part with the mold so we can get like the general shape, the geometry we want. And then once we get it on the car, we can do all the final body work. So in
Yeah,
this
yeah.
case, we just added like some painter's tape over the seams to make sure it was essentially like sealed. We added, I think it's called XC3D. It's like a two-part epoxy resin just to seal
Hmm.
up the print that makes it like essentially watertight from our friends at Smooth On.
Yes.
And then we applied a gel coat, which helps the fiberglass separate from the mold itself.
Wow. So using a regular 3D printer to build a car part mold. Now you've seen everything. Amazing. All right. Oh, so now we see how it actually looks on and when installed on the car, right?
Yeah, yeah. So, I mean, I'm always blown away with just how I could go from like staring at something on my computer day in and day out and then seeing it in reality. And I think it truly is a testament to like PL3D and like the scanning technology that's out there now because I mean I've been scanning for a couple years now and I remember people always like being concerned of volumetric tolerances and errors and whatnot, which is certainly a real thing to worry about. But I mean, this is a, correct me if I'm wrong, I would say a fairly large and aggressive part for really just to be exactly where we want it to be.
Hmm. Yeah, no, absolutely. And there's so many things that could go wrong when building
Yeah.
something like that, but the fit is pretty amazing. So it's mesmerizing. Yeah, and I think we have another angle. Yeah.
Yeah, so you could see we still have like to we added some clecos and like ABS sheet just to like hold it in place, but
Hmm.
really the goal was just to get like the lip roughly where we need it, and now it's a matter of just feathering in the fiberglass and getting the part completely bonded to the car. And
Great.
then we're gonna still make it's like some taillight housings and things of that nature, but now at least we know like where everything's gonna go.
Yeah, the rough part's over, right?
Yeah, absolutely.
Great. And before we get going, we actually have a video which I'm going to bring on screen, showing the entire process. So yeah, I'm going to start it, and Tyler, if you want to comment over and describe what we see on screen.
Yeah, absolutely.
All right. So that's you scanning the car, as I can imagine.
Yep, so that's 3D scanning the car. You could see we're getting some good data of like the frame rail and upside and inside the car. Now here was the CAD process. I like to use the zebra stripe to make sure, like from a body perspective, like all the body lines make sense. It's nice and fluid. And then this is one of the 3D prints right when it came off of the printer. And then here into the assembly of it where we use some clay to fill the voids. And that was the two-part epoxy I was mentioning
Hmm.
onto the gel coat, fiberglass, and yeah, laying out the fiberglass. And we just did it by hand, just rolled it with some resin, pulled the part, did a little bit of body work,
It's amazing.
and threw it on the car just like that. Super simple, right?
Yeah. Yeah, that's crazy. I mean, it's something you could do in your garage or your basement. Well, you need a good, well ventilated basement, but still, I mean, it's amazing. Wow, great. So, so before we keep going, I think we're going to move on to the interactive part of this presentation, and we're going to ask you to let us know what you want to see next. So I'll just go back to my screen here. So in a few seconds, you're going to see a survey pop up on screen, which I'm going to be distributing. So what do you want to see next, or what do you want to hear from Tyler next? This is what we're asking from you. So we have different topics, different choices that we can talk about. So we'll give you a bit more time. I see answers are coming in, and Tyler, things are lining up for people being interested in seeing about the reverse engineering in CAD part of things. So maybe you want to bring us to SolidWorks. Yeah, I think I'm going to give yeah. Yeah, let's move on to the reverse engineering in CAD part of the presentation. So I'll
Yeah,
just close that and make you presenter in a second, if I may. There we go.
there we go. Can you see my screen now? It should be showing
We
SolidWorks.
can see it. Yes.
Perfect. So, as we were talking about before, here is the 3D scan imported into SolidWorks. It's a little bit easier to show if you just shut off wireframe. So the way I really went about doing this is when I do complicated shapes like this, I often like to get a little bit of the floor because that's like a guaranteed flat, especially when you're dealing with such like an organic or complicated shape. And then while it was a little bit unnecessary to get underneath the car, a big thing I wanted was the frame rail. Because when we're trying to align this to an XYZ coordinate system,
Mhm.
this is a very easy spot. Like we've got a flat here, and what I wound up doing to find this center line, and I like to think I just kind of got lucky in this particular instance, is I did an average plane between the two frame rails, and it was perfectly in center with the body,
Mm.
which also is a testament to how Rob and his guys put the body on the chassis because they did recenter it and they did a fantastic job. So from there, I did some surface modeling. Let me change the wireframe back and I will hide the scan. And on the surface modeling, I want to say like a 3 curve, compound curve loft to create this bottom panel, which is really what was the most important feature here because that was what's non-existent on the car. And we actually increased the fillet here for the quarter panel because we felt that looked a little bit better and had it basically blend into like a very simple curve down here, which is more just getting into the style of it, not necessarily the reverse engineering. But this is where you kind of let the artistic vision go, create the surface model you want. And once you get your shape, we could hide the surface and show the solid bodies.
Huh.
So off of that surface, I basically did a surface cut off of a large solid body and created this mold that we worked off of.
Mhm.
So I made it. Let's see. Let's do a quick. I want to say it was like a quarter of an inch maybe. So we're working with like a good thickness, something that wouldn't warp too easily when we're working with the fiberglass because that gets pretty hot when it's curing.
Yeah. Did you print it to a full density, 100%, or did you use some infilling?
No, we did I want to say like probably 3 to 5 walls, and I think
Mhm.
only 10 or 20% infill.
Oh,
And so we did it pretty sparse, but that's really because we only need to make one part. If you're going to make more, I would
mhm.
definitely consider using either a higher grade material or a higher infill, like really making it a much more robust part. And that's not to say you can't make more than one out of these, but I would say you're limiting yourself to only a couple.
It's a low production volume mode.
Definitely, definitely.
Right, right.
And then since this shape was so complex under here, that's where I modeled um, these supports, which we sent over to Send and got them made out of MDF, which again saved us a lot of time and money on 3D printing.
Mm-hmm. Wow. So are you planning to do other molds like these for the car parts? Is that how you plan to build the other components or?
Oh yeah, absolutely. So we also did the hood scoop on the car itself.
Okay.
That was 3D scanned, modeled, and molded in a very similar fashion to this. We also, the next one we're going to do, and I already scanned it, I just haven't finished the modeling of it, is we are going to make the inner fenders of the car itself too. Because right now there's no, the hood is essentially just sitting on top of the car. There's no inner fender whatsoever.
Hmm. Wow. So in the end, this is really going to be a one of a kind, right?
Oh, without a doubt, yeah. This is, I think, about as custom as they come.
Awesome. Any ideas for when you plan to have this finished?
We were hoping to debut it at SEMA this year.
Ooh.
So we certainly have a lot of work ahead of us, and we'll see where that goes. But that's what we're hoping to do right now.
So you heard it, people. That's a good reason to go to SEMA this year and visit Reversion Raceworks and their booth over there. Pretty fascinating. Great. So I think we're going to move on now to the question part of this webinar. So again, if you want to ask your questions, you just go to the question section of the GoToWebinar interface. We do have some questions already, which we're going to start answering. Let's see now. Oh, maybe that's a fun one. Uh, yeah, we got Andrew here who's interested to know how much filament did you use to build that mold? How much spool did you use? How many spool actually?
Is a lot a sufficient answer?
Well,
uh,
it's a reference, yeah.
no, it's so I want to say we went through, let's say, like 7 3 kilogram spools.
Oh, yeah, that's pretty good. It's actually not that bad, especially given that these are relatively affordable. So it's, I mean, for a mold of this complexity, I guess
Hmm.
it kind of makes it, it keeps it affordable. All right, great. Let's see now. We have okay, this one. There's a question from Rob. We answered it already. There's a question from Airman here. What printer did you use to print the mold sections?
We internally have like modified Creality CR10S5s, so they're a 20 by 20 inch cube, and we just do some modifications to like increase the temperatures they can handle and make them a little bit more robust and reliable.
Okay. And what was the I want to say the injector size, or what was the nozzle, the size of the nozzle that you used for that?
We used a zero point 0.6 nozzle with a
0.6.
0.35 millimeter layer height.
Okay. Wow. There's another question here from Paul. Did you have to take special measures in to ensure your custom body part would fit?
So one thing we did do is, and this was just a pretty simple way of going about it, if you could still see my screen,
Mhm.
um, we took a tape measure just from like roughly this point all the way to the opposing point once we assembled the mold, and it pretty much measured right on what we expected it to. So that was like a good sanity check before we made the fiberglass part, because like we mentioned before a little bit, there's the potential for volumetric error of the scan itself. There's also could be like a little bit of discrepancy with tolerance of the 3D print. But once that checked out, we were pretty confident it was going to work right then and there.
Mhm. Nice. Have another question from Rainer here, which I think I'm going to be the one answering it. If you have a 3D scan and you want to remodel it in CAD, how can you verify that you have modeled all features, or can you compare it to the 3D scan file in peel.cad? So the um, the comparison or the inspection feature is not something that's included in peel.cad at the moment. It's something that's readily available in VX Model, which is Creaform's solution to reverse engineering. But I'm guessing, Tyler, that you can also do it in CAD, right? You can at least do some visual inspection, I guess, or how did you do it on your project?
I'd say pretty much visually inspecting it. Like it's
Mhm.
just a matter of like showing and hiding and really just looking at this part all day and
Right.
night until I get it where I want it to be. So there's no shortage of hours into this part, to say the
Of course,
least.
no. Yeah,
Um,
at least with the scan, you know where the lip actually is and where it needs to fit in order to sit right when installed on the car, right?
Yeah, and one like little trick I do just to keep myself sane is as I'm designing these things, I like to try to think of it as like at a higher level. Like, what am I trying to achieve? What features need to be included? Like, as I think of it, I'll write down like add a lip for the upper panel to bond to the car. Make sure there's 3 taillight holes. Make sure the quarter panel is extended a half inch so it's like extra material to cut away. Like if I think of like little design things that'll improve the process, I'll write them down and keep them in a notebook that I look at while I'm modeling, just so like I remember those notes, I remember those cues, just so I don't forget it throughout the
Hmm.
process.
Nice. There's a question from Brian here who says, how are you constraining the new sketches surfaces to the existing scan data?
So once what I'll do typically is uh, do the alignment in PLOS, and then once it's aligned, you can import that scan into SolidWorks. And the once you import it and make sure it has like the correct scale and whatnot, then the coordinate system comes with it. So once that coordinate system is created, I will start modeling it based around the scan to make sure everything is on the same coordinate system.
Hmm. Great. Uh, there's another one here from Alessandro. After the scan, to make the mold, is it one surface area added?
Could you repeat that, please?
Sorry, to make the mold, is it one surface area added? I'm not sure I get the question, Alessandro. If you want to add some clarification to your question, um, I'm not sure. And then there's a question about Creo. Are you familiar with Creo, Tyler? Or
I've never used it, but
okay.
so I'm not sure I could be helpful there.
Okay, so Erman, we'll have to get back to you on this because there was a question about how to process for reverse engineering using Creo. Unfortunately, it's um, the great thing with Peel.os and Peel.cad. There's actually a direct transfer to SolidWorks in Peel.cad that allows the user to create interfaces and entities and transfer them directly into SolidWorks in order to use them as references. So you're basically allowed to extract some information. As of now, it's not a feature that's integrated into Creo, so these can be exported as regular surfaces and then likely imported into Creo. I'm not so familiar with Creo, but yeah, the workflow would be slightly different. Yeah. So I guess that's it for today. I think we do we have other we have other questions coming in. So yeah, we'll take maybe one or two more. Yeah, wow. Um, yeah, okay. This one is great. This is a good one from Michael. Michael asks, can the data collected be used for CNC sheet metal forming?
Yeah, it absolutely can. So whatever equipment you're using, it really just comes down to what file type you're trying to output. When it's coming to a CNC machine, typically they're looking for like a step file. When it comes to printing, they want like an STL or 3MF. So once you create the solid body, I mean, you can import scan data, and people have done it. I think it's a little more difficult to work with just raw scan data, and I typically recommend using the scan data as like a reference to create your surface model or solid model. But once you create the data, whether it be in Solidworks or Fusion 360 or whatever CAD software you're using, you can import it into whatever manufacturing process you're trying to use.
Right. Yeah, makes perfect sense. And then, okay, so there's some clarification from Alessandro. I think when metal shaping after buck is made, it's typically one surface area removed to get to the true final surface area. Does the same apply to buck making in 3D printing?
So I believe he's referencing like the thickness of the part, like
Mhm.
what you're trying to achieve. So in this case, I just butted everything up with no tolerance. I just made them a perfect fit, but that's because I had already compensated for the thickness here. So when I did the surface model of the actual part, so I'll hide the solid bodies, and let's see. I made sure when I modeled this portion of the car in relation to the scan that I was modeling it from the outside, because I knew with
Mm,
this being the outer surface that when we add fiberglass, we'd be increasing the thickness on the backside, which is
right.
fine. We wanted this to be essentially flush with the body, which is
Yeah, yeah.
why I made it that way.
Mm, nice. Okay, last question of the day, and I think there's a bit of unanswered questions. We will not have the time to run through all of them, but we'll get back to you with answers. But there's James here who's asking, what do you recommend in for a mid-entry level 3D scanner to work with you guys at Reversion for CAD and manufacturing? So Tyler, what would you recommend?
So recommending the scanner itself.
Yeah, a mid-entry level 3D scanner.
I mean, really, we use Peel, so I mean, we really don't
That's a
that
good
we.
answer.
um, I really think when it comes to, I understand it's for shops and people getting into this industry, it might be a little bit intimidating of a price point, but uh, it really is such a deal. And I don't just say that because I'm on a webinar with Peel. Like I say that because I truly do believe in the product, and I have used other scanners. And in my experience, the lower end equipment, the stuff that may be a bargain in the, let's say, $1,000 range or what have you, you spend so much time with headache and problems and troubleshooting and a lack of support that it really just isn't worth the money. So if you're looking to get into it, I would suggest um, starting with the base package that Peel offers, because it's very affordable. You could always upgrade to the Peel CAD software. You could always get all the bells and whistles at a later date. But I would really heavily recommend start with a scanner that you know you can use, that like, and if there's an issue, these guys are great to work with. Like when with these other solutions, a lot of the time there's no technical support. You have a problem and you're kind of stuck with it. So if it were me, that would be my suggestion, is just save your pennies a little bit if you can't afford it right now, and get something that you know you're going to use for years to come.
Awesome. Great. So that's a wrap for us for today. I want to thank you, Tyler, for joining in and showing us this amazing project that you guys are working on, and we'll definitely be on the lookout to see it at SEMA this year. So people listening, if you want to see us, PO3D is going to be at SEMA as well as Reversion Raceworks. So we hope to see you there. We thank you for your time today and for listening to this presentation. We hope you enjoyed. If you have any questions or things that come up afterwards, drop us a line to hello@po3d.com. And again, thanks for being with us today. So have a
Yeah,
great rest of your day.
and feel free to reach out to us directly too if you have any questions specifically about the car. You could email us sales@reversionraceworks.com or contact us on Instagram at reversion_raceworks.
Yes, absolutely. Yeah, it's a good point. Follow both PO3D and Reversion Raceworks on Instagram. That's where a lot is happening, and you're going to see this project come together and the latest and greatest about this fantastic project going on. So thank you again. Thanks,
Absolutely.
Tyler.
Thank you for having us.
Have a good one. Bye-bye.
You too. Bye-bye.